Okay, LSAT PrepTest 22, Section 3, questions 1 through 7. This is the first logic game of this test. Okay, so what do we have? We have at a benefit dinner, community theater, 7 sponsors, K, L, M, P, Q, V, and Z, will be seated at 3 tables, 1, 2, and 3. Okay, of the sponsors, only K, L, and M receive honors. Let's say honors is this blue. And then, what else? Only M, P, and Q will give a speech. So M, P, and Q will give a speech. Okay, sponsor seating assignments must conform to the following conditions. Okay, so it's pretty clear to me that there's going to be 3 tables here. We're going to be asked to dump these 7 people into these 3 tables, right? And then these additional categorizations are probably going to mean something. I don't know what they mean yet. Okay, so each table has at least 2 sponsors seated at it, and each sponsor is seated at exactly 1 table. Ugh, I can't talk. Well, that makes our lives much easier, right? That just means that there's, it's 2, 2, and 2, and then the last slot is going to be in one of these 3. We don't know where it is yet, but it floats between one of these 3, right? And also it tells us that one sponsor, one table per sponsor, I guess is the way that should work. Basically, that there's not one sponsor hogging multiple seats at multiple tables, right? Okay. So any sponsor receiving honors seated at table 1 or table 2. Okay, that's a big piece of information. So anybody who's receiving honors, this blue underline, can't be seated in table 3. So K, L, and M have to be in either 1 or 2, right? We distribute them in 1 or 2. So let's actually get rid of that because that's redundant. Let's actually get rid of this stuff. The 7th slot, I guess we can just leave there floating just so we remember. Okay, third rule: L is seated at the same table as V. L and V have to be together. So immediately, just visually, what we see is that K, L, V, and M have to be in these 4 seats, right? Whether or not this 5th seat enters the picture at any point, we have no idea, because it can go anywhere, right? But we know for sure that these 4 guys sit here, meaning what? It leaves that P, Q, and Z are the only eligible people to sit in table 3, right? So these 4 are distributed between these 2. These 3 are distributed between are the only ones that can sit here, and then this last slot is the one that actually just messes everything up, right? So depending on what information they give us, we're going to have some additional legwork to do. Okay, so let's just jump straight into the question. So question 1: which of the following is an acceptable assignment of sponsors to tables? So just simple process of elimination, right? So first, each table has at least 2 sponsors seated at it. Okay, that eliminates answer choice E, it looks like, because Q is the only one seated at table 3. The rest of them are fine on that front. Okay, and then K, L, V, and M have to be seated at 1 or 2. So in answer choice A, L and V are seated at table 3. K, L, V, and M in answer choice B, M is seated at table 3. In answer choice C, L and V are actually just split up entirely. There's no way that can be true. So answer choice D has to be the answer here. Okay. Which of the following is a list of all and only those sponsors, any of whom could be among the sponsors assigned to table 3? Oh, we just figured that out. It's P, Q, and Z. That's answer choice C. Right? I mean, this is very, very straightforward. The ones who could be assigned to seat 3 or table 3. So if you didn't make this inference up front, they force you to make it in question 2. Okay, question 3. If K is assigned to a different table than M, which of the following must be true of the seating assignment? Okay, so what we have is our seating assignment 1, 2, 1, 2, 1, 2, right? And now we have to split up K and M. So we have no idea whether they go in 1 or 2, but we do know that they go, one of them goes in 1, the other one goes in 2, right? And then consider this other thing we have in the middle. We have to put L and V with one of them, right? But it can only go with one of them. So one of these slots is going to have a 3rd slot in them. And what's more, that means that there's going to be one empty slot that's going to have to be filled by one of these guys, right? So basically, one of these 3 guys is going to have to be pulled over here so that we can properly fill all of our slots. Okay, so which of the following must be true of the seating assignment? Okay, so answer choice A, B, C, D, E. Answer choice A says that K is seated at the same table as L. That doesn't have to be true, right? We just said K, M, L, V, and then pull one of these guys over to sit with K. That's not true. How about B? L is seated at the same table as Q. That could be true. Actually, no, that couldn't be true because L and V have to sit with somebody, and that's your table of 3, right? So there's no way that we can pull Q over to sit with L. And answer choice C: M is seated at the same table as V. It could be true, but it could be KLV, and then one of these guys sits with M, right? And in general, these three answer choices, immediately when I see that I have such little information, and I know that this guy can switch, I'm immediately suspicious of answer choices like that, because we just don't know enough to be able to say these things with concrete certainty, right? And this is a must-be-true question. Okay, answer choice D. Exactly two sponsors seated at table 1. That doesn't have to be the case, right? Because whichever one of these is at the table of 3, there's no reason it can't be table 1. Which leaves answer choice E. Exactly two sponsors seated at table 3. That has to be true, right? Because we're pulling one of these three guys over here, because there's going to be a table of 3 and a table of 2 within these first two tables, which means that there's only 2 guys left to fill this third slot. Answer choice E is the correct answer here. Okay, question 4. Q is assigned to table 1 along with 2 other sponsors, which the following could be true of the seating assignment. Okay. So, 1, 2, 3. Q is here along with 2 others, and then we have 2, and then we have 2. Okay, so, given that we know that K, L, V, and M all have to be here, what do we know? That we know that P and Z must be on table 3, right? And then these guys we can kind of distribute however we want, right? We know that L and V have to be together, so either L or V are going to take up these 2, or they're going to take up these 2, which means that K and M in this case must also be together, right? So let's actually reflect that by just rewriting them. So not only do L and V have to be together here, now K and M fill the other one, and they go in either one. We just have no idea, right? Okay, so what are they asking us? They're asking us which of the following could be true. Okay, so let's actually do this and then evaluate. So K is seated at the same table as L? No, that can actually never be true, right? Because L and V are together, so K and M must also be together. How about B? K is seated at the same table as Q? Yeah, if we put K and M here, L and V here, that's perfectly fine. Answer choice B looks good. Answer choice C, M is seated at the same table as V? That can never be the case. Answer choice D, M is seated at the same table as Z? That can never be the case. Answer choice E, P is seated at the same table as Q. That can definitely never be the case. So yep, answer choice B does turn out to be the correct answer here. Alright, let's move on to question 5. If the sponsors assigned to table 3 include exactly one of the sponsors who will give a speech, then the sponsors assigned to table 1 could be any of the following except. Okay, so now we have one guy who's going to give a speech. Exactly one person who's going to give a speech, which means the other person isn't. Right? Well, look what we have giving speeches. We know that it's not going to be M, right? M has to sit in seats 1 or 2, in tables 1 or 2, so it's definitely not going to be M. So it's one of P or Q that has to be here, right? So one of P or Q is here because exactly one person who gives a speech, and then who else could sit here? Z. So Z has to be in table 3, right? And then the rest of these we kind of don't know, right? The other one of P or Q is going to be dumped here along with K, M, L, and V. Right, and these guys are going to inhabit tables 1 and table 2. We don't have any specifics. That's another key, right? Because they're asking who could be assigned to table 1 except, right? So basically the answer I'm looking for is Z, and it's actually right there. It's answer choice E, right? And how do I know that? Because all the rest of these guys could be assigned to table 1, right? Depending on on how you want to split these guys up, how you want to dump them, wherever you want to dump them, it just doesn't matter, right? Like the only element we know for sure is element Z in table 3. Right, so K could be here, M could be here, P could be here, right? If Q is the one who's over here, and and Q could be here if P is the one who's here, right? So the switch is key to recognizing the correct answer choice here. So it turns out answer choice E, yes, is the correct answer to this question. Okay, let's go ahead and clear off our worksheet and see what we can do with 6 and 7. Okay, so question 6. If 3 sponsors, exactly 2 of whom are receiving honors, are assigned to table 2. So 1, 2, 3. So we have 3 sponsors at table 2, being 2 sponsors each at 1 and 3. Exactly 2 of them are receiving honors. So exactly 2. Okay, then which one of the following could be a list of sponsors assigned to table 1? Okay, so once again we have our K, we have our M, we have our L and V together, and we have P, Q, and Z left over. Right? Who are the ones getting awards? K, M, and L are the ones getting awards, right? Okay, so what do we have? We know that that everybody who receives an honor is going to be at 1 or 2. So that means that the third person who's getting honors has to be at table 1, which means again, like one of these guys is going to have to come over and sit with the award winners. Okay, so they're asking us now, which of the following could be a list of sponsors assigned to table 1? Right? Okay, so basically in table 1, our criteria are we can only have one award winner, and other than that, and one of these guys can come over. Other than that, anything goes. Right? This is +1, which is one of these guys. So the answer was A, K, and M. Right? K and M is 2 award winners. Right? K and Z, sure, one award winner and one guy extra, meaning that we put L, M, and V here, giving us 2 award winners. That seems pretty good. Right? How about 3? P and V. P and V being here means that there are no award winners, right? So that's not going to be it. P and Z, again, 2 guys here means that there's no award winners at table 1. Answer is E. Q and Z, again, like these 3 are exactly the same. This leaves 0 honors at table 1, and you just can't have that. All right, so it turns out answer is B is the correct answer, and the way that looks is if you put K and Z in table 1, then you put the remainder of them, so L and V, who have to be together, right? And then M as well, and M is actually the one who gets the honor here, right? So his dash is blue and V's dash is black, and then down here you have what's left. You have P and you have Q, right? So that's the answer to the question. Its answer was B. All right, last question. Which of the following conditions, if added to the existing conditions, results in a set of conditions to which no seating assignment for the sponsors can conform? So basically, now, in addition to everything else that they've given us, now they want us to make it impossible to seat people, right? So let's just go through these. Let's figure it out. So answer is A. At most, 2 sponsors are seated at table 1. Okay, that's fine, right? 2, 3, and 2. We actually just proved that that's possible. How about B? Any sponsor giving a speech is seated at table 1 or else at table 2. Oh, okay. This is where it gets tricky, right? Because now in addition to the 3, honors givers, we now also have these 3 speech people, right? And so if everybody who gives a speech is seated at either table 1 or 2, what does that give us? Let's actually draw that out. Right, that means that K, L, and M are seated in 1 and 2. We have M already, so P and Q, who are giving speeches, also seated at 1 and 2. And then remember this rule, right? This rule that L and V have to be together. So we have 1, 2, 3, 4. We have 6 elements split between 1 and 2, which means that there's one lone slot over here in table 3, and you can't have that. Our first rule explicitly tells us we have to have at least 2 at each table, right? So answer choice B actually looks very strong in terms of giving us an impossible scenario. Let's look at the rest. Answer choice C. Any sponsor giving a speech is seated at table 2 or table 3. That's fine, right? Like that. That's actually again proven out by question 6. Like these speech M, P, and Q, M, P, and Q. That's great, no problem. How about D? Exactly 3 sponsors seated at table 1. We proved that earlier, right? And really all you have to do is swap around 1 and 2 LVM KZ, and you get a valid arrangement of elements. So no, that's not going to be it. And how about E? Any table at which both L and V are seated also has a third sponsor. That's fine, right? You just keep doing this, right? L and V and then third sponsor, which means there's just 2, the other 2 at table 1, and then 2 people in table 3. That's perfectly fine. Right? So it turns out answer choice B is the only one that results in an impossible scenario here, and so therefore that's the answer they're looking for. And that's the entire game.